All right, sorry, I have both my screens on, helps if I'm on actually the right thing. There we go. I do have my chat up, so if you need to ask a question or have anything for me, you can always just interrupt me as well. But we're just gonna pick a few more problems and then I'll give you a little bit of time, kind of like yesterday, to try a few more. You can see if you have any questions and we'll go from there. Yesterday, what number were you guys working up to? 12? 12, okay. So we'll just pick a few after 12. For the people at home, I can give you the answers for the other ones. I'll do that in a few minutes. I'm giving it to the people in class. Just so you can check the ones that you did yesterday. So we'll just pick a few, kind of like we did yesterday. Like some of these take a little bit, so I don't want to kill you by doing a million of them. But it's good to see just different setups in general and going from there. So yesterday, I think a lot of the ones you did were proportion. So I'm a big proportion fan. If you see that setup, go with it, because why not? It makes life a little bit easier. I'm just moving you guys over a little bit. Come on, oh, I'm gonna walk. All right, there we go. So I have a little more room. So if I see a proportion setup, I'm pretty pumped about it because I feel like it's a little bit easier, but a lot of them are proportions. So I'm just gonna kind of pick random ones because I know there's a few that I wanted to skip around and do instead of doing them in order for this case. So let's start with we'll do 15. Because I definitely want to do 20. We'll probably do 19 too, and then we'll pick one other one. So I'm just gonna pick a random one. So 15, we have x plus 6 over x equals a -5. So I go into any problem just thinking, well, first, it's not a proportion, so if it is a proportion, go for it. So I think to myself, well, I really don't want fractions, so how do I get rid of them? And that's multiply everything by the common denominator. So in this case, the common denominator, remember, if you want to throw these over 1, the common denominator is just x. So we're going to multiply through by x and kind of see what we get. We get x squared plus, those x's would cancel and I'd be left with 6. I don't know why I set it up. Usually I've been doing times x on each one. I just felt fancy with this one. And that's going to equal -5x. There wasn't anything too exciting going on, so I just kind of put the parentheses. Just as a reminder, when you see a quadratic at this point, you want to set it up to, it should be factorable. So make sure it's in standard form equal to 0. So I'm going to move this 5x over here. And once again, standard form means we have the quadratic term, then the linear term, then the constant equals 0. So always x squared, x constant. So the factoring of this should not be too terrible. What do we get? X plus 3, x plus 2. Just be careful with signs. People always want to do 6 and 1, but they'd have to be opposite signs, which wouldn't make sense since everything's positive. And then that gives me my two answers of -3 and -2. Before you say that's your final, go back and check. Everything should be fine, right? Because if I plug that back in, there wouldn't be any restrictions or any zeros in denominators. And that would be number 15. So that one wasn't bad. Any questions with that specific one? Okay, let's do one, we gotta jazz it up a little here. Let's do number 19. Can I fit it next to it? Can I do it? Yes, I can. Okay, so 19, I like the one, a little jazzier. So we start, I'm just in the mood that I don't feel like writing this 1,000 times, so I'm just gonna start factoring my denominators as I go. I notice the first denominator has a GCF, so that would be 2 times y plus 3. I notice my second denominator is factorable, so that would be y minus 4, y plus 3. Okay. And then the last one's all set, so we don't have to do anything. So this one was kind of quick. That one, you might have to organize yourself a little bit more. I kind of get into the zone where I just remind myself what the common denominator is. In this case, the common denominator would be 2 times y plus 3 times y minus 4. So you don't want to forget anything. Don't forget about that 2 and just take the binomials. So everything has to be accounted for. And then in this case, I'm gonna write them individually because this is a little bit more complicated than that first one. Sorry, I know I'm probably writing a little small for the people at home. I'll try to write a little bigger. And kind of step away for a second. Okay. All right, so now let's do some canceling. The 2's cancel. The y plus 3's cancel. So I have 5 times y minus 4, which gives me 5y minus 20. Please be careful on this next part. So I'm going to start canceling stuff, which is fine. The y minus 4, the y plus 3. I have 2 times that, which I'll distribute, but this is a negative, so please make sure that minus goes with both terms. So it would be minus 2y times 2 is 4y. And then I have minus and negative, which would turn that to a positive 4 times 2 is positive 8. So it's not necessarily the hardest math, it's just like little things that you can lose as you go. So be careful when there is subtraction that you do give it that minus to both terms. And last but not least, the y minus 4's cancel. I have 3 times 2, which is 6, and then I'm going to distribute that in, and that will give me 6y plus 18. All right, so definitely looking way better now. Main goal is I don't want fractions anymore, so we definitely dealt with that. I'm just going to start to simplify. I notice on the left I can combine like terms. Minus 12. It doesn't really matter which way you solve it. I'm going to move this y over here. I like to keep things positive. If I subtract 18, sorry, I can't not write out steps. It's just my life here. I get negative 30 equals 5y, so y would equal negative 6. What a beauty. So in that case, we didn't have to factor. There was no quadratic terms. Maybe try for the right side. So you just kind of go through and combine what you can and isolate that y. I go back and check, and that should be fine, right? It's not gonna give me any 0 denominators or anything fancy like that. So that would be my final answer for 19. I'm just gonna pause for a moment. At the current moment, are there any questions, 15, 19, or anything in general? At home? The next one I need. What did you say? Sorry. Yes, that is an equal sign. It's just an ugly equal sign. It is. Thank you. Okay. The next one, I just need a little bit of room, so that's why I'm giving people a second. We are going to do number 20. Ooh, that one looks delightful. How exciting. Now, if you look at the left side of that fraction, we had seen one like that before. They were called complex fractions. It's basically when you have fractions over fractions. It can get a little bit annoying. But we actually know how to solve this. So we're just going to go through our steps. We're going to take some deep breaths. We're going to remind ourselves of like, what steps do I know? I'm going to erase this. Does anyone still need 15 or 19? Okay. So let me do 20, and then maybe we'll skip around and do 1 or 2 more. Okie dokie. Number 20. Okay, so this bad boy needs some room. So we have 2 over x minus 3 plus 1 over x plus 3 over 1 over x squared minus 9 equals 5. Okay. So it's not the nicest looking problem, but we just want to take into account, what do we know? We have a fraction. I know there's fractions in the fraction, but just kind of focus on this is a fraction. You have a numerator, you have a denominator. Now, the nice thing is there's no other terms over here. You just have one fraction. So what we're going to do over here is just make a fraction. Because this is just going to be a proportion problem. We like those ones. Those ones are nice. You just cross multiply it. So don't overthink it and start doing crazy stuff. There are other ways to do it. But if I did the other way, it would confuse you, so I'm not gonna do it. So just keep it to the proportion on these ones. So just think about what we're doing. We're taking everything in this numerator and multiplying it by 1, okay? So 1 time, you can put 1, I mean, we don't really need to put it, but you get the idea. Okay. And then with a proportion, we put an equal in the middle, and we cross the other way. So we have 5 times 1 over x squared minus n. Okay, so we're looking a little bit better. Now at least we don't have fractions on fractions. So over here, obviously the 1, I'm just going to keep it as 2 over x minus 3 plus 1 over x plus 3. I just want to simplify this right side. When I have 5 times that fraction, the 5 is just going to multiply times the numerator. So that, would be 5 over x squared. I'm going to factor the bottom while I'm here. Sorry, so I don't need to rewrite it. I'm just going to factor that bottom to x plus 3, x minus 3. Okay. But the main goal of the 5 is you just multiply by the numerator. So now, the main goal is just to kind of simplify our setup and get it to a point where we can actually do something about it. And this looks kind of like all the other problems we've been doing. I have an equation, there's fractions, I want to get rid of them. I'm going to multiply by the common denominator. In this case, my common denominator would be x plus 3, x minus 3. So once again, I go do my little steps. I'm going to multiply everything times x plus 3, x minus 3. There's x plus 3, x minus 3. Sorry for the people at home, I'm always squishing it in here. But I'm just taking that common denominator and multiplying each individual thing by it. And then see what magic happens. X minus 3's cancel. I'm going to kind of write over there. I'm going to distribute it, and I got 2x plus 6. Here, the x plus 3's cancel. If I distribute a 1, I'm just going to get plus x minus 3. And then here, the x plus 3's cancel, and the x. Why did I write a 1 here? Okay, I just went crazy. Sorry, that should be a 3. I don't know what the heck I did. I'm sorry, that will cancel that. I don't know where that 1 came from in my brain, but that's why I need to always check this out. And that just equals 5. So actually now this equation isn't all that bad. We're just going to do some quick solving. 3x plus 3 equals 5. So 3x is going to equal 2. So x is going to equal 2/3. How will that work for that little answer? Excuse me. So I'll leave that one up for a second. But main goal, when you see something that looks weird, just try to relate it to something we already know. Technically, it was just a proportion because we could put that 5 over 1. If you have a fraction equals a fraction. Once we cross multiplied, that made the setup way easier for us. And then we just went back to the steps that we kind of already knew. Yeah.
When you multiplied it to the 1 in over x squared minus 9, you did 5 over 1, right?
Yeah, exactly. So that's why you just multiply 5 times the numerator. Yep. Exactamundo. So I just wanted to show you that one. Because once again, if you had come across that one, you'd be like, what the heck is happening? But always try to relate it back to things that you already know how to do. I'm just trying to see if there's any other like cray ones. I don't see anything too crazy that should mess you up too much. Oh, let's do 23. I feel like sometimes the easier they are, the more confusing it can get to people sometimes. So let's look at 23, and then we'll just see if there's any you guys want to go over. I'm happy to do so, or we can just kind of try a few. It's one of those things, once again, you have to kind of try it on your own to see if you're good. But any questions on 20 before I erase it?
So it shows that most of the data is. So you see that our histogram, take a look. Looks like most people got, this year, they got like,
So 23, we get 2x minus 4 over x squared minus 25 equals 0. Zeros freak people out, I don't know, like making things easy freaks people out. Ready? It's a proportion, okay, so I always do that. If I just see a fraction equals one thing, there's no other terms, I always make it a proportion. You can always put whatever is here over 1. Cross multiply. 1 times 2x minus 4 is 2x minus 4, right? Equals 0 times anything is 0. Okay, so that entire thing just kind of cancels out. 2x equals 4, x equals 2. Done. So once again, don't overthink it. If you can make something in proportion, do it. So if you see a whole number, you can always put it over 1 and cross multiply. Don't get freaked out by the 0. I feel like if you were doing that on your own, some of you would be like, not sure. You second guess yourself. So little things like that, we just want to be comfortable. I don't see anything else that should be too crazy. The rest of them are all pretty similar to ones we've been doing. So yesterday we did up to 12. I know we've skipped around a little bit. We'll save a few for tomorrow. So today, do as many as you can. Let's leave we'll leave 25 to 29 for tomorrow. So up to 24. That makes sense. 12 yesterday, 12 today. And then we'll save a few for tomorrow just as a review. So people here, you guys are working for a few minutes. We'll take our math break in a few. People at home, I'm just going to give you the answer to yesterday's problems so you can do them if you need to. So I am going to stop this.